Most people reading about NASA's new chip are thinking about space exploration. Private markets investors should be thinking about capital allocation. Here's the story, and then the investment thesis. NASA is currently testing the High Performance Spaceflight Computing processor, a chip small enough to fit in the palm of your hand that operates at 500 times the computing power of the radiation-hardened processors currently used on active space missions. The chip was developed through a partnership with Microchip Technology, a NASDAQ-listed semiconductor company, and is currently undergoing rigorous testing at NASA's Jet Propulsion Laboratory in Southern California, including radiation bombardment, extreme temperature cycling, and high-fidelity planetary landing simulations. Testing began in February 2026 when engineers sent a symbolic first email with the subject line, "Hello Universe," a tribute to the classic Hello World message used in early computing history. So what does this chip actually do that current space processors can't? Current spacecraft often rely on processors equivalent to mid-1990s desktop computing power, useful but not capable of real-time decision-making on difficult terrain or in rapidly evolving situations. When something goes wrong on a spacecraft operating near Mars, the communication delay between Earth and the spacecraft can be anywhere from 3 to 22 minutes each way. You cannot wait 44 minutes for a round-trip command in a crisis. The new processor enables autonomous spacecraft to use artificial intelligence to respond in real time to complex situations where human input isn't possible, analyzing environments, navigating hazards, reacting to unexpected conditions, and processing massive streams of sensor data almost instantly. Mars rovers today rely on computing power roughly equivalent to a mid-1990s desktop. The HPSC chip could let Mars rovers and lunar landers think for themselves. That's the science story. Now here's the private market story. Microchip Technology is delivering the HPSC processor not just to NASA, but to the broader defense and commercial aerospace industry. Early access samples have already been provided to U.S. defense and aerospace contractors. And critically, Microchip is already adapting the design for commercial Earth-based applications, including aviation safety systems and autonomous vehicles, sectors where a single hardware fault can be catastrophic and radiation-hardened reliability is a genuine competitive advantage. Apollo Global Management Co-Resnick. This is the pattern that private markets investors who follow the defense tech thesis should recognize immediately. Government-funded R&D creates a validated, hardened technology. The primary contractor, in this case Microchip Technology, commercializes that technology into adjacent civilian markets. And the entire supply chain around the primary contractor, the power management, the thermal systems, the testing infrastructure, the integration software, becomes a private investment opportunity. The 2026 geopolitical climate has specifically favored Western-designed, Western-manufactured chips in aerospace and defense sectors, where Microchip's heritage gives it a competitive moat that Asian semiconductor competitors cannot easily cross. The CHIPS Act has accelerated domestic semiconductor investment, and the HPSC program sits directly in the beneficiary category. For private equity and venture investors tracking the defense tech thesis, the same thesis driving Apollo's industrial renaissance deployment and the Anduril and applied intuition headcount explosions we covered earlier, the space autonomy computing segment is one of the highest conviction subsectors in the portfolio. The autonomous spacecraft market is not a distant future bet. The chip must clear JPL certification by late 2026 to stay on its deployment schedule. The commercial rollout into aviation and automotive begins no earlier than 2027. The private capital formation opportunity is in the infrastructure around this technology. The defense contractors integrating it, the testing and certification services that qualify it, and the software layers that make autonomous spacecraft AI actually work in deployment. Cohen-Resnick. When NASA validates a technology at JPL, private capital follows. The pattern is consistent. The timing on this one is now. Subscribe for private markets investment thesis breakdowns delivered weekly.